Hello everyone. In this session, we are gonna explain simple and fractional distillation. As you see, in this session, we are gonna separate a mixture of liquids. In previous session, we explained um, crystallization, and you know that the crystallization is meant for purification of solid compounds. But here we have distillation, which is meant to separate liquid phase. Distillation is a physical process for purification of solids in which a mixture of liquid is separated. This method works based on difference in relative volatility of compounds in a mixture of liquids. This process is used in a wide range of industries, from beverage processing companies to refinery and petrochemical plants. So as you see, simple distillation has three components, major components. A boiling, uh, a boiling happens inside the round bottom, boiling a liquid mixture, and then the condenser, which is the condensing of the vapor, happens in condenser. But before that, we have the three adapter that direct the vapor to condenser, and then we have a graduate cylinder to collect the liquid, which is condensed already. So simple distillation cannot separate a mixture of liquid with close boiling points. So we need at least 25 degrees of Celsius difference between boiling points. If they have a close boiling point, they cannot separate it. We again uh, obtain a mixture of them. So we at least we need a good difference between two liquids phase that we want to, between their boiling points that we want to separate. A good example can be water and methanol, that they have a delta T of 35 degrees. The mixture is in the round bottom, as you see, gradually heated using a heating mantle. Around 65 degrees, methanol will be evaporated and directed to a three-way adapter, then condenser, where it changed to liquid methanol. Around 100 degrees, we also can collect water in another graduate cylinder. So in this slide, you see the fractional distillation. It has four components. One component extra compared to the simple. The extra is as you see, is the fractional column before three-way adapter. And in this slide, we are explaining the mechanism of the fractional distillation. We have we have the issue of closed boiling point. So in order to address this issue, we 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 cannot use the simple distillation. So we are gonna use the we cannot separate the mixture with the closed boiling points in simple distillation, but it is resolved using fractional distillation, because vapor is passing through a fraction of the fractioning column before entering into condenser. So to cool and to be collected in the collection flask. As you see inside the fractional column, there are hundreds of obstacles inside, which they restrict a smooth pass for vapor. So Vapor heats obstacles and condense to liquid. This condensate inside the column will be turned into vapor again by the rising vapor. So vapor undergoes a cycle of condensation and vaporization inside the fractional column that results in a pure solution of the more volatile compounds following uh, the Raoult's law. So, the mechanism of fractional column is based on Raoult's law. You need to remember, and how we can separate liquid phases with a very closed boiling point through a cycle of condensation and vaporization. We have the hundreds of obstacles in front of the vapor, so it causes the vapor to be condensed, and after it condenses, it warm up again with the rising vapor that it's behind that condensate. So that rising vapor again heat the condensate, and that condensate turned again to the vapor. So we have a cycle. In this cycle, we see that at the end of the story, we can get a pure separated liquid phase. So if we want to look at the laboratory procedure, you see that it's very simple for simple distillation. Actually, please note that to the instruction, as you need to fix all the components by clamp, we need a mixture of 20 milliliter mixture of uh, water and methanol inside the round bottom. So heating the mantle is gonna place on the ring clamp. In case something happens, you can lower the ring. And here you see the uh, fractional setup. Uh, we are we are gonna use the copper wool uh, because we want to heat the mixture thoroughly, and we want to to heat all the phases, all the liquids at the same time. All four components should be fixed with the clamp. Again, all precautions should be considered. So you need to consider that the water should enter from the bottom and exit from upper exit. Why we need to do that? Because we want to fill the whole condenser. On the other way, we'll fill partially the condenser. And dial the transformer to 50, and then use the small beaker for storing the first liquid, and then use the graduate cylinder to store the second uh, liquid that you obtain, which is water. At the end, you need to make a table because we are using the graduate cylinder. We can see the amount of liquid that we are storing inside the graduate cylinder. For each milliliter that you obtain, you need to record the temperature. At the end of the experiment, you have solid waste and you have glass waste, and you need to use the proper waste storage for all of them. Thank you